Hello and assalamu alaikum to all of you. Welcome back in my new tutorial. I hope you will be fine. In this tutorial we will find envelope correlation coefficient of 2x1 MIMO antenna with the help of far fields. So I have calculated all these far fields, and after that with the help of post processing different ways post processing I have find this envelope correlation coefficient. So in this tutorial I will show you how to find this envelope correlation coefficient. So for that, first of all, you will need to come to field monitors, and field monitor you will select far field, and here you will change frequency to samples linear, and from here you can change number of samples, and I left it for you. You can change it according to your need. By applying and pressing OK, you will then you will need to come to here, and here you will just simulate your antenna. So before simulating antenna, you should need to check your far field monitors over here. So after few minutes you will get your simulated results is like this. Now you will need to come to post processing and selecting template based post processing. From here you can see far field antenna properties is already selected over here, and then you will come to far field results, and here I will need to select MIMO envelope correlation coefficient, and I will come to all results, and here I will select monitor, browse monitor. So here you will need to select any. You can select either your first band or second band. It's depend upon you, but from here you are just browsing your monitor. Now you will need to come to MIMO, and here you can see envelope correlation is already selected over here. You will just need to browse your results from over here by pressing OK, and again by pressing OK you will get envelope correlation coefficient. So here you can see our envelope correlation coefficient is calculated or here, which is its accuracy depend upon the number of samples you have which you had calculated. So here you can see at this frequency my envelope correlation coefficient is also almost equal to 0. So from here you can see this is equal to 0, and when it's come to 2.5 to the power minus 5, so it means it's close to 0. And at this frequency you can see this is also again equal to 0.03. It means it's a good results over here. So for now, take care, bye bye.